Hi everyone, I hope you're having a good day. Today we're going to talk about investigating functions. So let's start off by talking about a function and what is a function. So a function is a relationship between inputs and outputs. So let's write that down. A relationship between inputs and outputs. So what's an input? So ultimately we're going to say that an input are our x values, which is also known as our independent variable. And our outputs is our y values, which would be known as our dependent variable. So our y value is going to depend on whatever our x value that we put in is. The key part when it comes to a function, and we're going to explain this a little bit in more detail, is there's only one output for each input. And that's the key kind of definition when it comes to a function. It has to do with that input and that output, and there only being one output for each input. So let's kind of walk through an example a little bit and see if we can kind of figure out what all of this terminology means. So let's say we have y equals x minus 2 squared. So our x values, what we put in for x is going to be our input. And we're going to put a number in for x and we're going to get a number. And that's going to give us what our y equals. So our y is then our output. So there's a couple different ways that we can show this relationship with the function. We can do equations, we can do XY tables, and we can graph. So we're going to go through all three of these. So let's start off with a table. So let's say we have an XY table. So we're going to just randomly pick some values for x. So let's say we start with -2. So that means I'm going to take -2, which is my x value. I'm going to input that in for my x. I'm going to simplify, and that's going to give me my y value, which is my output, which is going to go here. So I would have -2 minus 2 squared. -2 minus 2 is -4 squared. -4 squared is 16. So let's try it for -1. So if I put in -1, I would have -1 minus 2 squared, which would give me -3 squared, which is going to give me a positive 9. Right? Let's try some more. If I put in 0, 0 minus 2 is -2. -2 squared is going to give me 4. If I put in 1, so I'm going to put 1 in here for my x. So I'm going to have 1 minus 2. 1 minus 2 is -1. -1 squared is 1. If I plug in 2 for my x value, I'm going to put in 2 for x. So 2 minus 2 is 0. 0 squared is, of course, 0. What happens if I put in 3? I got a little extra room over here. If I put in 3, 3 minus 2 is 1. 1 squared is 1. And let's try one last one. Let's try 4. If I put in 4, right? So if I put in 4, 4 minus 2 squared, 4 minus 2 is 2. 2 squared is 4. Right? So this is what we refer to as a, they usually write it as XY table. Right? So if you see them asking for an XY table, that's what they're looking for. They, of course, another example would be an equation, and this is an equation, of course, right? So this would be an example of an equation. So then the last one would be to make a graph. So we can make a graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Right? So when I actually look at our table are XY values, which are coordinate points. A coordinate point is an XY value. So I can go through and I can come up with all of these XY values off of my table. So my first point, my X value would be -2 and my Y value would be 16. So that would give me the coordinate point -2, 16. Okay? The next point I could get would be -1, 9, 0, 4, 1, 1, 2, 0, 3, 1, and 4, 4. Right? And I just got all of those from our table, our X and our Y. There's a relationship between these. When I use the input, I ended up getting this output. And when it comes to that 1-to-1, or that where there's only that one output, so when I put in -2, I only got 16. There's no other value that I can get if I put in -2. The only answer I can get is 16. And that's what they mean by there's only one output for every input. So now that I have my coordinate points, I can now plot those on my graph, right? So let's start with -2, 16. So -2, 16, that's really going to be way up here off of the chart, right? -1, 9, -1, 9, that one too is still way up there off of what we graphed. The third one was 0, 2, so X is 0, 4. X is 0, Y is 4, so I'm going to go up 1, 2, 3, 4, and I can put that one right there, right? My next point is 1, 1, so I'm going to go over 1 and up 1, and there's a point. 2, 0, I'm going to go over 2 and 0, so there's another point. 3, 1, I'm going to go over 3 and up 1. And last but not least is 4, 4. So I'm going to go over 4, 1, 2, 3, 4, and then I'm going to go up 4, positive 4, 1, 2, 3, 4. Well, that's going to give me a value right there. So when it comes to our functions and graphing these, they're continuous, so they're continuous and smooth is the best way to explain it. So I'm not just going to draw like these little two pieces together and leave it the way that it is. And it's smooth, so I'm not going to have like anything like that. That's getting a little extreme. So we want it nice and smooth. So when I see this, it's called a parabola or a U shape. And I can see it's kind of not necessarily perfect, right? Because we were not doing this on legit graph paper, but we get a very good representation, as accurate as possible that we can get. And functions continue forever, so we need to make sure we have these little arrows on the end of our graphs so we know that those that it continues and it doesn't stop. So if we go back, and so this, of course, is then the graph. So the three types of representations of a function, we can represent them as an equation, we can represent them as an XY table, and we can represent them as a graph. Right? So let's look at this equation just a little bit more for a second. So we had the equation y equals x minus 2 squared. So now that I always laugh and call it the, now that we're in the advanced Algebra 2 class, we're going to get a little bit more fancy when it comes to our notation. And we're going to use what we're going to call function notation. And it's just a nice little fancy word. We're going to write this in a fancy way. So instead of writing the y, we're going to write this as f of x equals x minus 2 squared. So the only difference is instead of writing y, we're writing it as f of x. And what we're ultimately saying is that this part is a function of of x. So this is a function of x. And then the way we read this, we say that this f of x equals the x minus 2 squared. Right? So it's f of x is how you say that. So this is great when it comes to us looking at inputs and outputs, because let's say I wanted to find, I can write it as f of 3, and I want to know what f of 3 equals. So when we're evaluating these functions, if we're just writing the function, it's f of x equals x minus 2 squared. But now I want to evaluate that function, and I want to evaluate that function with this 3. And what do you think the 3 is going to go in for? That's our input, right? And our input is our x values. So wherever our x is, we're going to put in a 3. So we're going to have 3 minus 2 squared. So this is just going to say f of 3, and that's going to equal 1 squared. So f of 3 equals 1. And the nice part about this shows you your input. So when I put an input of 3 in, I get an output of 1. So if we write it in that function notation, we'll always see what the input and what the output is. And that's what's key for us right now, moving through some of these problems. I hope you guys found the video useful. If you guys have questions, make sure you're joining that Zoom meeting at the beginning of the class hour to ask any questions. And I'll talk to you later. Have a wonderful day. Thanks. Bye.